All right, so for this type, we need to be able to figure out how we write the square root function that shifted 5 left and 1 up. All right, now, first of all, as soon as you see the word square root, well, we should know then kind of the general format that we're looking at, right? So we know there's going to be a square root in the equation. So I'm going to go ahead and start by writing that part down. So we got the square root. It's just a matter of what's going to be inside of our square root. Well, we know that one thing that's always inside the square root is x. Do we have anything added or subtracted to our x in this problem? Well, the number that's added or subtracted to the x, which way does it move it? It's usually either left or right. And yes, we do have that kind of a shift going on here because we're told that it's moved 5 units to the left. So that means the 5 needs to go inside with x. All right, now if I'm going to go to the left here, is that plus 5 or is that minus 5? To the left is plus. Always. And that's not unique to square root. That's true for all of our different function types. Plus goes left when it's inside with x. All right, and then we want to go 1 unit up. That means that 1 is hanging on the end. Now, if we're going to go 1 unit up, is that plus 1 or is it minus 1?
Plus 1.
Up is plus. And again, that's true for every function type that we've seen. Plus goes up, minus we move it down. Now, notice we've now accounted for everything that this one told us. Square root, so I got the square root symbol over it. Sometimes we get so caught up in the pluses and minuses, we forget that. So do make sure that you did that. And we got the 5 left, and we have the 1 up. Since we took care of everything, all I got to do is add a y equals to make it my final answer. That's now the equation of the function. All right, so for this one, it's going to be linear. Now, linear means that we don't have any fancy function operations in there. It's just a plain old x. There's nothing over it or around it. Now, if I want to move up 7, that means we got a plus 7 hanging on the end. Last thing, yes, include the y equals. So this is all you got to do for your equation here. Y equals x plus 7. All right, so for this one, we have an absolute value function. So that already tells me I start by putting in some absolute value bars. I know the x has to be inside of those. Yes, we do need to have something inside because it was moved either left or right. In this case, right. And so if we're going to go right 3, I put the 3 on the inside, and right is minus. So you should have an x minus 3 on the inside of your absolute value, and then to move it down 9, on the outside you have the minus 9. Make it y equals, and you're done. All right, so for this one, we know it's a quadratic function. Now, quadratics, we know that means that it has to be squared. But some people end up running into trouble writing these out because some of you will start by writing x squared just like that, and then in order to move it 4 units right, you'll then go minus 4 like that. But that doesn't look quite right. That's not going to mean the same thing because this would actually be moving it down 4. Because I have to do the x minus 4 before anything else happens to it. So, yes, we do start with the squared, but rather than making it x squared, make it the whole parentheses squared with the x on the inside. Start by writing it that way, and then you can put the 4 in with the x. That way we're doing the x minus 4 before we do the squared, before anything else happens. And then, of course, to move it 2 units up, we put the plus 2 on the end. Y equals makes it an equation, and we're done. So that's a little trick. The quadratics tend to be toughest just because we have to remember those parentheses being in there. So now we're still continuing on with the same ideas, except notice this one adds one more transformation. Look at how that would end up showing up in this. All right, so in order to approach this one, we see the absolute value function. That's the first thing I'm always looking for is what kind of equation is it? And so absolute value tells me I start with the absolute value bars, and I got to have an x on the inside. All right, the next thing I hit, so I dealt with that. The next thing I hit is reflected across the x-axis. Now that reflection across the x-axis means we have to make it negative. Specifically, the negative goes in front of the function. It doesn't go inside the absolute value, it goes out front of it. All right, then we have the shifted down 8. Well, since it's up and down, that means it's hanging on the end. So down 8 is going to be hanging on the end. Now when I wrote this, I left room on the inside of my absolute value to move it left or right. I didn't have a left or right movement. So, yes, technically the way it's written is right, but it looks kind of weird, so I'm just going to grab the eraser. It's the beautiful thing about using pencil on these. Move that absolute value bar to be right after the x in this case, and then put your -8. That way it just looks a little bit cleaner. But then, this is our final answer. And when you're doing these sorts of things, actually we need the y equals. And when you're doing these sorts of things in WAMAP, you go through the same process. You type in the function first, then you start plugging the stuff into the function. Just kind of plug it in. And so starting this one, the first thing I notice is it's a square root function. So the first thing I'm putting down on my paper is a square root symbol. And of course, the x has to be on the inside of that. All right, next up, I just did the square root part. Next up is the reflection across the x-axis. All right, so again, that means a negative has to be out front of it. And when I say out front, I mean out front of the radical. It's outside of the square root. And then finally, shifted left 10 units. Since it's left to right, it has to be in with the x, so it's going to be inside the radical. Make sure that radical bar is going over the 10 as well. And to go left, that's plus.
Why is it negative square?
Notice in this case, there's nothing hanging on the end because there is no shift up or down. You're just kind of letting the description or the graph, whatever it is, tell you how to build the equation. Right, for this one, it's linear. So that means it's just going to be a plain old x. There's nothing fancy in my x. There's no absolute value bars, no parentheses needed, nothing like that, because it's linear. All right, so linear just means make it x. Next up, reflection across the x-axis. So again, that means make it negative. In this case, that just means make it a negative x. And then the last thing, shifted up 1 unit. So that means having a +1 hanging on the end. Notice the reflection does not change the up-down sign. Up is still plus. So this is it. This is your final answer. This is what it should be looking like. No parentheses or anything like that here. All right. So this is our next layer that we're going to be going to with this. Is we're still going to write the equation of the function, but now it's no longer just told to you that it's shifted this way or that way and all that. We actually are going to need to be able to do it from the data, from the numbers. Take a moment, write down this table really quick on your paper. And one of the reasons why we learn about all these different function types and how they behave is because eventually down the line we want to be able to look at real numbers that are happening and decide what kind of equation would be best to represent that kind of a situation. And so we're going to start with nice pretty numbers, but they'll eventually get less and less pretty. We want to be able to write the equation of this function. Now, some of you are looking at that table and you already know what the function is off the top of your head. That's great. You're more intuitive with these. You've developed a good sense for what's going on. That's good. I like that. But I want to also give you a tool that you can use when it isn't so obvious, because some of them, they're not going to be obvious. So if I gave you the graph and you could see how it was shifted or something like that, or what the shape was, you could do it. You could write the equation from that. And so if you're ever looking at a table of values and you don't know what the equation would be, make a quick sketch of the graph. Now, it doesn't have to be a perfect drawing of the graph. I have a nice pretty scale here with a grid, but I don't even need that. I'm just going to make a quick sketch of what's going on. So I'm going to plot these points and see what that would look like. And so when I plot those points, I can see the shape of the graph. Now this graph should look familiar, right? If I connected those points into a curve or a line, whatever they told me to make, I'd get a curve here, the U-shaped graph. Now, whenever we get an equation or a graph that looks like that, what type of equation is it? Yeah, this one's the quadratic. So it's like we're starting by knowing that this is a quadratic equation. Oops. All right, so we know it's quadratic. Has it been shifted at all? No, because it's starting here at 0, 0. Has it been reflected or anything like that? No. So really it's just a quadratic equation. What's the equation look like if we call it quadratic? A quadratic always has something squared And so our equation would then be y equals x squared. And some of you, again, you just looked at the table and you saw that because you saw, oh, if I just square my x value, I'm getting that y. And that's great. I love it if you see that. But know that sometimes you won't always see it that way. Now, what benefit is there to being able to write an equation for something? It actually lets us answer a question like this. You notice the question up here changed. We want to figure out here, if x equals negative 10, what would the value of y be? Okay, so I don't really want to have to find some pattern and extend it up in this table. That would be a pain, especially going up to negative 10. But that's why we have an equation, because I can do it much more easily. So if I want to figure out this answer, I'm going to go y equals negative 10 squared. Now note, I put the negative 10 in parentheses. That is important. If you left off the parentheses, it would look like this. Y equals negative 10 squared. That actually means something different. This would mean do the 10 squared first and then make it negative. And obviously that's not what we mean to do. We mean to square the negative 10. So put parentheses around it. But what is negative 10 squared? A negative times a negative is a positive, and of course 10 times 10, yes, is 100. So y would equal 100 here. By being able to write the equation, it allowed us to figure out other values beyond just what is given in the table. It lets us extend our knowledge into areas much faster and much easier than we otherwise could. Oops. We're going to do the same kind of thing with a number of different problems here. This is a new table of values. So take a moment, write down this new table, and then think about how would you figure out what it would be when x equals 15. Now as a hint, you'll notice I gave you a graphing grid. Because some of you, again, you're going to look at this table and you're going to see, okay, I know how I can turn that x into that y. But in this case, probably most people won't. And in which case, if you don't know what the equation is, sketch a graph. Because if you can see the graph, you can write the equation for it. So, I'm going to go ahead and just start by plotting each of those points. And so when I plot the points, I'm looking at this. Now notice, that's all straight. Basically what we're looking at here is we got a straight line going through. And so we know it's linear. Alright, so if we know it's linear, now we look at see, how's it been changed? Has this one been reflected at all? And actually, this is kind of a tricky one to look at for knowing if it's been reflected. Think about what the normal graph would look like. This is just y equals x. That's our normal linear. Well, notice that one's going upwards as we go to the right. This one's going down as we go to the right. So yes, it has actually been reflected. So it's been reflected across the x-axis there. Has it been moved at all? Yes, because normally it's going through 0 here. Even if you reflect it, it would still be going through 0. Now, in this case, some of you will think of it as being moved up. Some of you will think of it as being moved to the right. I tend to always stick with up and down if I can. So I'm going to say that it's been shifted up 2. So how do we write the equation of a linear graph that has been reflected and moved up 2? That'd be y equals negative x plus 2. Now this question didn't ask you to write the equation though, did it? But by writing the equation, we now can actually figure out what happens if x equals 15 without having to go over to my table and just count a whole bunch of times, which by the way can lead you into trouble if you miscount, because that's all you're doing is just counting. Alright, so I'm now going to take the 15 and I'm going to plug it in for x. So that will give me y equals negative 15 plus 2. And again, you'll notice I'm keeping that habit of putting whatever I plug in parentheses. So negative 15 plus 2, that's negative 13. And so that's my answer. The y value would end up being negative 13. All right, next problem. This one looks very similar to the last one. In fact, if you look at the table that you wrote down for the last one and compare it to this, you notice the only change is on this line. But otherwise, the two tables are the same. I'm giving you a different x value this time, but the two tables are the same except for that last value. Well, it is going to change things a bit though, because I'm not just going to be able to use that same equation, because that same equation would give me a different y value at the end. So again, I'll just plot the points and see what they would look like. And so when I plot the points, this is now what I see. Notice the big difference between the last one and this one though. I do see a lot of straight, but it bounces, because notice it bounces from going down to going up here. What type of equation does that tell us it's going to be? Which type of equation gives us the straight V shape? Absolute value. So we know it's going to be an absolute value equation. Alright, so our normal absolute value is over here at 0, opening up. This one looks like it's opening up as well, but it's no longer over at 0. It's been shifted right 2. So write the equation of an absolute value function that's been shifted right 2. You should be looking at that. Y equals the absolute value of x minus 2. Make sure the minus 2 is inside with the x, of course. Now that we know that, we can go ahead and figure this out. And thank goodness we aren't trying to do this one by counting, right? Because plugging in negative 130, it's a lot easier to just plug it into an equation than it is to try to count this way 130. So plug it in. Y equals absolute value of a negative 130 minus 2. Now remember, you got to do the stuff inside the absolute value before you do the absolute value. So negative 130 minus 2 is a negative 132. Notice I still got the absolute value bars around it. Now I take the absolute value, which of course means make it positive, and so y is just going to equal a positive 132 here. That is your final answer. All right, now for this one. We're looking for when x equals 100, fine, but we got a table again, and we got to see how we deal with this table. Now again, you could start by plotting each of the points and seeing what that gives us, although I can only plot some of them. Only these fit on my graphing grid. The 16, 25, and 36, they're off my grid. Now, you can make a grid that would fit them, but do you really need to? In fact, some of you, in fact, many of you, I dare say, probably didn't even need to go and make the graph for this one, did you? Because you started by looking at these numbers and are looking to see what happens. It's just that our numbers were all moved a little bit. Let's see how they were moved. So 0, 1, 1, 2. So it is a square root graph, but how's it been shifted? Yep. It's a square root function that's been moved up 1. So there's our equation. Y equals the square root of x plus 1. Yeah, so we could just plug the 100 into that. Y equals the square root of 100 plus 1. Well, we know the square root of 100 is 10. And of course, 10 plus 1 then is 11. And so then that is the answer. If x equals 100, y is 11. Now some of you might have noticed here on the graphics that I've been using, the grid has kind of been fading away. It's getting lighter and lighter. Because I'm wanting to remind you that the actual numbers on the grid aren't going to be quite as important as being able to see what the shape of the graph is and kind of where it starts. Because the graph that you're making on your paper, if you're choosing to make one at all, is there just as a reference for you, just as a way for you to be able to look at it and tell what type of graph is it and how's it been shifted or reflected or anything like that. And so if you plot the points, even just sketching them generally, you see a graph that looks like this. Well, what type of equation is that? It's a square root, absolutely. So I know I have square root of x. It's been moved though. Specifically, it's been moved left 3. Well, if I want to move it left 3, that means I have a plus 3. But be careful that you didn't write it like that. Do you see why?
Yeah.
Because this right now would be moving it up 3. When you want it to go left 3, make sure you extend that square root bar over the whole thing. Now that's the only change we made to it. We didn't move it up or down at all or anything like that. So this is your equation. Y equals the square root of x plus 3. And now that we have an equation, now we can plug our x value in. So y equals the square root of 78 plus 3. Well, I'm betting you know what 78 plus 3 is. Be 81, which conveniently enough is a perfect square, isn't it? Go figure. Almost like I planned it that way. Oh yeah. And because the square root of 81, of course, is 9. And so, since I got y equals just a number, that's my final answer. When x is 78, y is 9.